So you're going to find whatever the base is and stack it h high. Okay, that's it. You multiply. Area of the base times the height. Cylinder, if you want to be fancy, find the area of a circle. So change it to pi r squared if you want, but that's just because it's a circle. Then you're going to stack it h high. Same formula. This is Cavalieri's principle. So this is the idea that, I mean, you could include cylinder on this. That'd be a little harder to do, but it's basically whatever, if the area of the base, no matter the shape, if the area of the base is the same in all those figures, so like that middle one's like slanted a little, but it's like the area of the base are the same and the height's the same, it forces all their volumes to be the same. That's Cavalieri's principle. He sometimes references it on ACT, not often, but I've seen it, so I might as well just tell you that's what it is. They'll just like use the name. You won't have to like know exactly what it is, but they might talk about it. Volume units. Okay, so if you did volume of a prism, okay, versus volume of a cylinder, it would be volume of the prism. Your units for the base would say, and let's just do meters just for fun. So we'll do meters squared would be the area of the base. And then times, what the heck? What just happened? There we go. Times the height, which would be a length. So if you did this strictly algebra style, meters squared times meters is meters cubed. So cubic unit is what volume is. Okay. Cylinder, people freak out because of the pi, because this would be, what would be the area of the base? Pi radius, which would just be meters. If we did meters again, squared, that would be the area of the base. And then times the height would also be a length. The only difference is this one has a pi tacked on. It's still pi meters cubed. Pi is a number. Still's legit. What is going on with this? Here we go. It's still legit. You're still going to get cubic units. Okay, so volume is cubic unit, not square unit anymore. Okay. So here we go. I tried to do some trickier ones. The equilateral triangle is not going to go away. This is the shape that'll come up a decent amount in calc. I've seen it come up a lot. Some of you are still doing sine cosine for the height of this thing. You need to knock it off. That's not going to help you because you're going to have to do this no calculator with later stuff. So you just want to make sure you know how to do it. So, gosh, what is going on with this? Here we go. Keeps like exiting randomly. So basically what you do is you figure out the base and then you figure out what the formula is. So that's a triangle, 1/2 base times height. Okay, so if I were to find the area of that, all the sides are 14. The height's not 14, like some people on the test, hopefully. Okay, so the base is 14. And then the height, you have to draw it yourself. So equilateral triangle, you draw it yourself. This is a 30, 60, 90. So you cut the 14 in half and then you multiply by root 3. So 7 root 3. No more trig, cosine, tangent stuff with this, okay? So that, you find the area of that, and then you're going to stack them 22 centimeters high. So 22, and then you just tip-tap away, okay? The way I type this is I'll go 0.5 times 14 times 7 times 22 times root 3. I'll do the radical stuff at the end, because then I don't have to do a parentheses ever, which is nice. Okay, so then you tip-tap around and you get 1867.2 cubic centimeters. So it's multiplication. Surface area is addition, okay? Volume is just area of the base times the height. Area of the base times the height all the time. Okay. Number 2 looks all sweet and innocent, being like, oh, prism, that's like the easiest thing because I just go 20 times 60 times 8, unless you read it. Yep. Cubic yards. Yay! Yay! Okay. So cubic yards of cement, that's how you order your truck, okay? 60-foot long driveway that is 8 inches thick. Makes sense. You don't put that much concrete, you know what I mean, for the thickness of a driveway. And 20 feet wide. So we're gonna have to do some conversion business. So how many feet are in a yard? There we go. Everyone knows that. That's good. Okay, so what I'm going to do is I'm going to have to figure out what the dimensions are in yards. Sad day. I'm going to use the base as like the bottom. Since I get to choose, I'm just going to use the bottom. And then my little dinker 8 inches is going to be my height. That's my goal. Okay. So I'm going to do, for the base, I'm going to do just rectangle, you know, like full on rectangle. But then I got to divide 20 by 3. Oops, that would be yards now. Whatever decimal that is, I'll just leave it because I hate decimals. So that'll be the base. That looks beautiful. Just kidding. Okay, 60 is a little nicer. 60 divided by 3. 20. Okay. Some people think, oh, I'll multiply by 3. Really, 180 yard driveway. Really? You know what I'm saying? Like, think about it. That's a road. Okay. All right. Anyway. So we're going to multiply that. We'll deal with that later. And then the inches, ugh. That's just awful, but it'll be fine. We're going to get over it. Okay, 8 inches. So what do I got to do? To yards? So I got to go feet, then yards, probably. So what do I got to do here? I got to do 8 inches divided by 12 inches. That'll give me feet. So what is that, 2/3? Great, I love fractions. Okay, 2/3 of a foot. Then I got to take the 2/3 and divide by 3. That looks disgusting. So a little old school fraction work. Remember, dividing by 3 is the same thing as multiplying by 1/3, or dividing by 2 is the same thing as multiplying by 1/2. This is what I'm going to do. I'm going to do 2/3 times 1/3. It's the same thing as dividing by 3, but it's easier for my sanity. So 2/9. 2/9 of a yard. And then you're going to tap it out. Okay. So as far as tapping it out, what I would do in the calculator is do parenthesis 20 divided by 3 close times 20 times parenthesis 2 divided by 9. That's how I would type it all at once. Okay? If you have a graphing calculator, hit alpha y equals, and you can make a little fraction for yourself. But most of you don't have that yet, so 29.6 when you do type it. Okay. So, all right, so that's like the horrible one, is like doing the conversions and stuff, so kind of horrible. Okay, now this is the idea with this one, okay? Imagine, well, this is kind of it, right? So what I'm going to do is I'm going to find, this thing's hollow. So imagine like the hole like goes all the way through. So here, how about, I'll try to like make this look like something. Do you know what I'm saying? Like it's basically a prism, but you can't see it because it's like in there, right? So essentially the plan for this, again, it's not surface area. So this is a lot easier of a problem because you're just going to fill up the full thing and think of dumping out the water of the middle, right? So you're going to find the volume of this like blue one basically and then subtract the volume of like the hole, like the hollow prism idea, okay? So volume is volume of the, I don't know, big prism. Find the volume of, I'm just going to call it the hole or the hollow part, whatever. Okay. So the volume of the big prism, that's like area of the base. I mean, this is like, you could use our old school stuff from like elementary school, right? Because you're doing the area of the base, which is 8 squared. So 8 times 8 times the height, 14. This iPad's getting a little futzy today. So you're going to get whatever that is, okay? Now, the dimensions of the little guy is like a little weird, but if you do like a bird's eye view, maybe, to think about it, like of that top, it's like a picture frame kind of, maybe. So this is like the top, like bird's eye, right? So it's 8 by 8, but then all the like in-betweens are 2. So if all of these are 2, what's the dimensions of the square? 4 by 4, exactly. Okay. So you have to take out the 2 2s on the sides. So then the area of the base on this one is 4 by 4, so 4 squared. Or 4 times 4, I don't care. And then the height of it is the same as the box, right? Because it has to go through the whole thing. So this is also 14. And then you tip-tap away. 672. Cubic. You got to get in the cubic zone now because we're in volume life. Surface area on this one is very terrible. It's very hard, okay, to do all that because you have to add in all these like little pieces here and the inside. Surface area is a lot worse. Volume, you're just doing full volume, subtract or add, pretty much. Okay. All right. This next one, cylinder. Okay, same idea. Guys, please stop talking when I'm talking. Okay. This is the same amount of CDs as this. That's why you have to think of volume as a stacking. Okay. So all it is slanted over. It's still stacked 16 high, okay? So people try to do like all this like triangle Pythagorean theorem stuff when you don't. Like you just literally do pi radius, unless you want to be, what was it, 4 people who plugged in the diameter on the test. Okay, so pi r squared. Oops, I wanted to put that there. Okay. So pi r squared, and then you're stacking them, 16. That's it. Okay. Yeah, go ahead.
Why did you ask?
You do 4.2 meters cubed. Okay. All right, so slanted ones, just perpendicular, okay? Shh, girls, stop. Number 5. Whoa, is the formula different? Oh my God. Okay, so it's just on its side, like so down. It's just slanted, okay? It's just sideways. Okay. Okay, so pi r squared. Pi radius squared. Height's a little sassy because they just give you this like slanty random length, okay? Here's the plan. This be your height. Boys, stop talking. Can we please stop talking when I'm talking? Okay, now what is this length up here? Brooke, what's this length?
That whole length
Yep.
is 12.
Nope. 2.5 plus 2.5 is 5. Let's pay attention. Pay attention. Okay, so this is a triple. If you know your triples, it's a lot easier. So your height is 12. Okay? So you multiply that out, and you get 235.6 cubic meters. Okay. Inches. Oh! It's there. There we go. Okay, so that's it.